Some thunderstorms fade after one burst of rain, but others keep rebuilding themselves for hours. A multicell thunderstorm is not one storm cell doing all the work. It is a cluster of cells with young towers growing, mature cells raining heavily, and older cells weakening at the same time. The secret is organization. In a simple pulse storm, the rain-cooled downdraft falls back into the same place as the warm updraft. That cold air cuts off the fuel, so the storm often collapses within 30 to 60 minutes. In a multicell environment, moderate vertical wind shear changes the story. Wind shear means the wind changes speed or direction with height. When the shear is moderate, it tilts the storm just enough to separate the rising warm air from the falling cold air. That separation lets the updraft keep feeding on warm, moist air, while the downdraft lands nearby instead of smothering it. When heavy rain falls through the storm, some water evaporates and cools the air. This dense, rain-cooled air plunges to the ground as a downdraft, then spreads outward as a cold pool. The leading edge of that spreading air is the gust front, also called an outflow boundary. Think of it like a small, fast-moving cold front. As the gust front pushes forward, it wedges under warm, humid air near the surface and forces it upward. If that lifted air cools to its condensation level, new cloud towers form along the boundary. These towers can grow into fresh cumulus congestus, then into new thunderstorm cells. Meanwhile, the older cell behind them may be raining out and weakening. This creates the classic multicell cycle. Old cells die, new cells fire, and the whole cluster keeps moving. That is why multicell storms can last several hours and cover much larger areas than isolated storms. In Australia, the fuel can come from moist easterly winds off the Tasman Sea, moisture streams from the Coral Sea, or low-level jets from the tropics. The first lift may come from the Great Dividing Range, a dry line, a sea breeze collision, or an existing outflow boundary from another storm. On radar, forecasters may see a blob of cells at different stages, sometimes with a fine line ahead of the rain marking the gust front. If the cells line up along a strong boundary, the system may become a squall line. If the shear is stronger and turning, a supercell may form instead. Multicell clusters usually bring hazards such as heavy rain, flash flooding, frequent lightning, hail, and damaging straight-line winds from downdrafts. They are often less tornado-focused than supercells, but they can still be dangerous because their impacts spread across many suburbs or towns. The key lesson is simple: watch the outflow. When a storm throws out a gust front into warm, humid air, it may be building its next storm before the first one has finished.